Hello and welcome to the Adafruit Show and Tell. I'm Liz. I'm going to be your host this evening. If you would like to join the stream to show off your projects, you can find a link in the live broadcast chat on our Discord server to join. And our Discord server is available over at adafruit.it/Discord. First, we're going to kick things off with some Adafruit folks, beginning with Scott. Hey, how are you?
I'm sleep deprived. I'll tell
Fair.
you that.
Okay.
But that's what happens with a newborn. I've done some really experimental stuff, which I love to be doing experimental stuff.
Yeah.
And what I'm experimenting with is building, like putting CircuitPython on top of the Zephyr RTOS,
Okay.
which is a very popular kind of industrial grade, commercial grade real-time operating system. The main appeal for us is that we would get kind of standardized drivers for like Flash and Bluetooth and Wi-Fi across pretty much all microcontrollers.
That's very cool. Yeah.
And then on top of that, we get real-time operating stuff. So managing different parts of CircuitPython running on different cores, for example. So like people want to run SynthIO, and you have two cores on the RP2350, but like right now we don't kind of offload SynthIO or DisplayIO to the other core.
Right.
And to manage that well, we need a real-time operating system. So Zephyr is pretty appealing for that. So I've been working on kind of prototyping, moving the Nordic port of CircuitPython to Zephyr, with the idea that we can move all of them. But that's the first one. That's the first one I'm targeting. Also because the newer Nordic chips aren't well supported in the way that we've implemented the Nordic stuff on there. So I guess you could show my screen.
Oh, yeah. There we go. Red.
Red. Yeah, this command failed. It's a big, long command.
Oh, okay.
Things to note here is that we're using like Zephyr GCC, so we're getting kind of build information from Zephyr.
Okay.
So not only we're also inheriting all of their build information, which could be cool too. So which compiler to use, what flags to set, all that stuff we're going to inherit from Zephyr, which will make it, the reason that we started doing this work is we wanted to make it easier to port CircuitPython to new platforms. So if the platform is sort of supported by Zephyr, we want like this minimal port to just work.
Very cool.
Build tooling to do with that. And those who've seen deep dives know that I've had a bugbear about our build system. So the way I have it working is that the Zephyr build system is what you use from the outside, but then to build CircuitPython under the hood, I actually have some Python code that does all of the build system-y stuff.
Oh, great. Yeah.
Which is working pretty well. So I've got parallelism implemented, and I just tried to add a thing to make sure that like if no files have changed, you don't actually run the command again.
I see. Okay.
What you're seeing here is I'm hung up in the QString weeds, unfortunately. Which is one of these special things that MicroPython does to like share strings across things is this QString stuff. So there's this whole process where you like pre-process all your source files and you collect all the possible QStrings up, and then you replace those with numbers in your code, basically.
Gotcha.
But it's not working. I broke it because I was trying to like detect when I had to rerun it, and the QString script was not outputting the files names that I actually thought it should be named. It's just writing some other random names, which is great.
Gotcha.
So yeah, working on Zephyr. Before I messed this up, I was just about to do Flash system stuff. So Flash support for any of these chips just through their generic API, which would be really cool.
Very cool.
Yeah.
Well, it's always cool to see what you're working on, and we've definitely seen you start from like ground zero on things and get to like really amazing progress before you went out on a parental leave. We saw with the Circuit Matter stuff. So really looking forward to seeing you bring progress every week with the Zephyr stuff too.
Yeah, this will likely, I'm going to be on hiatus in a week or so for the holidays, but then if this week goes well, I'll probably pick it up back up in January.
Excellent. All right. Well, thanks so much, Scott.
Thanks, Liz.
Have a good one. Now we're going to hear from Melissa. Hey, how are you?
I have a couple of things to show off here.
Cool.
First of all, I had come on Show and Tell a couple weeks ago or so, and I had shown like the this RGB LED project. It was all breadboarded at the time.
Mm.
But now I have it so that it's on this proto board here.
Oh,
And
very
then
cool.
I also had designed this case here that goes over it and just snap fits. And this one
nice.
has a little infrared LED for it.
Cool.
And then I also had designed a version without an infrared LED because it only needed it one place. And then I can just kind of, if I wanted to design more of these, it's really easy at this point because I just need to throw together a proto board, print off a case, and it should be good to go.
That's great.
And then the other thing I wanted to show is I made my first keyboard here. This is with a 60% keyboard.
Nice.
And it's using the Maker Diary board for its underlying board, and it has the Kalo or whatever you say it, the key switches, the brown ones, I mean. And then I got these keycaps off at Amazon because
nice.
I thought they would go really well with this color scheme.
Yeah.
And so yeah, it has CircuitPython actually running inside of there. It works as a HID device.
Oh, cool.
Yeah.
And for the CircuitPython code, is that like I know there's like that KMK does it plug in with that, or is it straight up CircuitPython?
It's PyKB, I think is what it's using.
Okay. Yeah.
Yeah. So it's using that to do all the keyboard stuff. I haven't really customized the code at all at this point, but it does function at least.
Very cool. And does it have lighting underneath too, or?
I haven't played with that, but I think it has physically there's LEDs under each of the keys.
I see.
And like I don't know if you can see.
Yeah, I can make you full screen again.
Like if I hit the caps, you can see it lighting.
Oh, very cool.
And then you can see the little light here.
Yeah.
Showing that it's running. And there should be ways of like making it do like some RGB LED coolness. Yeah.
Sweet.
I played with that at least.
Nice. Yeah, that's great. And welcome to the keyboard pipeline to get really into that.
I think it's kind of similar to like a Jedi building their lightsaber or something like that.
Yes. Love it. All right. Well, thanks so much, Melissa, for showing those projects.
Thank you.
No problem. Have a good one. All right. Now we're going to hear from JP. Hey.
Hey, Liz. How you doing?
Good. How are you?
Good. Thank you. So I'm here in a much darkened workshop today just so I could show some lighting stuff that I'm working on. And if you can show my second screen there, this is a little DMX controller that I got for about 40 or 50 bucks on Amazon. So this one is using the DMX 512 protocol, which is a theater and architectural lighting protocol or messaging protocol. It's usually used for lights, but also for foggers and strobes and effects and pan tilt motors and things like that. You can program what your lights are going to do with this type of controller. And typically, if you have a lighting fixture, I've got these little cheap wash lights. This one has red, green, and blue elements on it. You'll plug that into your XLR cables and drive it directly. And it'll use one channel per feature that the light has. So on that particular light, you can set into kind of a 4 feature mode where you use like channel 1 for red, 2 green, 3 blue, 4 for brightness. What I decided to do was take the controller that you usually use and hook it up to, I've got a microcontroller over here. It's an Arduino and it has a DMX shield on it that allows me to either send out, which is what I had been doing previously, sending out to those sort of standard lights. But now I'm actually using it in reverse. I'm having it receive DMX control from this. And then what I've got hooked up is NeoPixels. But it could be kind of anything. Could be motors, could be any of your things that you physically connect up to a microcontroller that you want to drive with some data. These send out 0 to 255 over the DMX protocol, and you can daisy chain them, so you can have a bazillion things, 512 channels ultimately, although this cheapo controller only does 192, which is kind of weird. And so what I've got this one set up right now for is I'm using actually 8 channels, which is convenient on this particular controller. Some, lighting boards you'll see in a theater might have 64 faders wide or something like that, and a lot of them automated or pre-programmed. But here I'm just using a kind of a direct mode, and what I can do is I decided to set it, instead of to a channel for red, green, and blue, I decided I want to use hue saturation value, because I usually prefer that, which means I can just kind of scroll through. If you look at the sort of light on the left there behind me, and if I do them both at the same time, you'll see I'm just using a single channel to change 2 ends of this strip. And so I can actually reposition this last fader to say, what's the last pixel in my strip? This happens to be, I think, a 30 pixel strip. So now I can independently say, okay, let's make the beginning of the strip be purple and the end yellow, or
very cool,
fade that over to green. And I wrote some simple code to interpolate between whatever those 2 endpoints are. So I can change the brightness of those endpoints, crank up the full brightness there. I can adjust the saturation of those, although that's pretty boring because then we just get kind of a white light, and then continue to goof around with how long is the actual piece that I'm using. And if you coordinate this well, you can do like little Cylon effects and things like that. It's fun to use hands-on, but you can program all this stuff using these things. You can say, okay, record this position, that's scene 1, record another position, that's scene 2, and then just tell it to run between those on a timer or when there's music or whatever. Unfortunately, right before I came on here, I was adjusting something and I totally screwed up my remapping of these. So I can only use like a little bit of these last fader 4 and 8 to adjust the length of it, because otherwise it's trying to go like through the but I was excited to get this working pretty well, and I'm gonna show this on the workshop show tomorrow. I've got a guide that's about to come out that has kind of the first half, which was taking your code and sending out to standard lights, and then I'm going to add this on, which is taking your standard controllers and doing whatever the heck over on this side to NeoPixels in this case, but it could really be anything. So.
That's great. I bet there's a ton of people that would love to see how to use these with NeoPixels too. So I think it'll be a really great guide for folks.
Yeah, we have lots of NeoPixels and lots of fun designs and shapes. This is a strip of them that I just put in some Coroplast, but you could do it to any of your strips and individual ones and boards and star patterns and whatever you want. So.
Sweet. Yeah. Awesome. Well, thanks for working on this, JP, and I'm sure folks are going to find it a nice, handy guide.
Right on. Yeah, come on by tomorrow. We'll play around with it. Thanks.
Excellent. All right. Have a good one. All right, that looks like it's going to do it for show and tell tonight. Thanks, folks, for coming by. There is no Ask an Engineer tonight, but don't worry, they will be back next week. And of course, tomorrow at 4 p.m., JP will be live with his workshop show. So until then, hope everyone has a good evening, and thanks for stopping by. Bye.